In this video, we will learn how to draw the structure of a large molecule by using the fragments which are available built in Gauss view. For example, we are interested in drawing the structure of heptacene, which contains 7 benzene rings fused in a linear fashion. And if we go to the ring fragments and see what are the fragments available here in Gauss view, we can see that we have benzene, naphthalene, anthracene, but we don't have heptacene. We have this coronene with 7 benzene ring, but they are fused in a cyclic fashion rather than a linear fashion. And now we are interested in drawing the structure of heptacene, which has 7 like benzene units. And to draw the structure of heptacene, we have to select anthracene. And I will show you why I have selected anthracene. Let's say I select this anthracene and I clicked it twice here. If I clicked it twice, I get 2 anthracene units placed like this. Why I selected anthracene? Because it is 3-ring unit. The other one is 3-ring unit, and when we will connect these 2 rings together, we will make another ring, and ultimately we can get the heptacene. Now you need to know a few more keys here. There are 3 different keys which are important in this type of exercise, and they are called as Shift, Control, and Alt. Shift is for dragging. If I press Shift and drag, I will drag the entire system, whether it is combination of 1, 2, 3, or 4 molecules, whatever the case is, your entire window molecules will be moving. But if I press Alt plus Shift, then I can drag one molecule selectively or one fragment selectively to the other one. I'm pressing Alt plus Shift, Alt plus Shift. Now, if I press Alt only, I will be able to rotate one fragment, and if I press Control, I will be rotating both fragments. And similarly, if I press Alt plus Control, we can rotate the fragments, one fragment selectively to the other one, but in a different axis. So let's say we are going to connect them together, and you can see they are not in the same plane. I have to press Alt plus Shift to drag it down in the plane of the other molecule. And now you can see here, they are still not aligned. They are aligned in one axis, but they are not aligned in the other axis. And if you do that, Alt plus Shift, now you can see they are relatively better aligned. So now you can see they are relatively in a better position to be aligned. And now we can delete these hydrogens and replace them with carbon, and then we can connect them together. To delete the atoms, I have to press this icon, which is saying delete atoms. And now I select a carbon atom to be placed on it. I select carbon here. And let's say I'm going to select I can select carbon trivalent, or even this one, which is aromatic type, or even we can select carbon atom. Let's say we select this carbon. There will be problem. I prefer not to select this carbon, which is sp2. I prefer to select carbon atom here. Why I selected this carbon atom, you can try yourself the other one, carbon sp2, and see what is the problem there. So if I do this, I can get these atoms placed here, and now I can make a bond between them. To make a bond, I have to select this modify bond. I select this one, and now I select this one as maybe double bond or partial double bond. Let's say I select this double bond here, and I decrease the bond length to 1.43, make it more like aromatic. Similarly, I can do this. I can make a double bond, and I can see it is already 1.43. I've joined them together. Now you can see 2 hydrogen atoms are missing here. We can add valency. And here you go. You got the structure of heptacene. And just to make sure that you have drawn the structure and it's good enough, you need to clean it. How can you clean it? You can see this icon says clean. And you can check if you clean it, the structure should be even better. And if your structure get worse, you have to look for the problem, why there is some deformation. Typically, it happens when your bond, like bond length and bond types are not defined properly. And if I click clean here, you can see there is no deformation. It's perfectly fine now. And now it is good for starting any calculation. Hope you have understood how to draw a complex molecule from the fragments which are available in Gauss view.